Okay, now the point is, okay, we have seen how what is the interface between the human and the computer, and the point is, certainly each programming language or uh, package, let's say programming mathematical package, have a structure, and we need to define the commands in a manner that a computer can understand, in the order, in a certain order. So for this purpose, there is a certain, each computer evaluates each command in a step-by-step manner that you enter to the computer. So it begins from the first command and continues with the next one. So if you want a certain task to be done by a computer, you have to give it in a certain order. And the first step that we do is to make a fictitious order in our brain. But in the first times of the software development or programming, people were using flow charting. So what's the flow charting? That's the point. We know that what is a synoptic is, because we are mechanical engineers, right? And sometimes we need to develop a process for the manufacture of a certain product. For example, a bracket or a conveyor or idle pulley or something. Certainly you do not manufacture that thing in one process, and there is a process line, and what you do is you while developing the product, you put or you devise a synoptic. So synoptic is the flow chart, right? At each step you put the process, and as an outcome of the process you decide what to do next. And this is the same for the software. We have the flow charting, and in fact we have different symbols for different operations, and regardless of the programming language that you are using for a certain task, this flow chart is the same. It doesn't change. So when you change the programming language, the only thing that you change is the command, which is proper to the code. So first symbol is terminal. So it is the start, it is the end, and whatever it is. So that is the terminal, and it's something like an ellipse. Then we have the flow lines. So basically these flow lines are the lines which connects each operation and tells us in which direction we will go. Next thing is the process. That's the command. And for simple process, it is a rectangle. Input and an output. For example, you want to input a command by using input a variable, sorry, not a command, input a variable by using a keyboard. Then you have an input here. Or you want to read the data from a file. Again, it's an input. You want a computer to give you an output to the screen, for example. That's an output. Or to the speaker. That's an output. Okay, decision. What's a decision? Okay, remember that we have seen the conditional statements, and you make a decision there. So if x is greater than something, that's a decision. Okay, so we have the junction, and so basically junction is the crossroads between different parts of the code or software. So that is the junction. So off-page connector, and what you do is, okay, sometimes what you do is inside of a conditional statement, for example, or in a do loop, even if the do loop is not fully done, you want to get out of the do loop, or you need to get out of the do loop because of a certain condition. That is, you say that, okay, do this operation 10 times, and then you say that if certain value is greater than this one, then get out of the loop. So that is what the off-page connector is. And you have the count control loop, so that is basically the loop. These are the symbols for the flow chart. I do not use it in general. I don't know if there are any people who uses it still, but these are the things that were used in the first times of the computational software engineering, let's say. Okay. Now here we have a simple flow chart. Let's look at it and let's analyze it. Now we have a condition, okay, and if this condition is not satisfied, the code will follow the false line. You go here, and then there exists another conditional statement. Now if the condition is satisfied, then you have the first block, and then next step will be this junction. Okay, let's continue with the false step. So if it is false, there are two possibilities. One is false and the other one is true. If this is true, again it goes to a block, and then it goes to the same junction. So it does this operation and then go there. But if it is false, check in another statement, and if this statement is false, do this operation. If this statement is true, then do this operation and go to the end. So this is how this is one structure that we generally face with. And let's look at the Potato code. Now Potato code is much more used in these days than using a flow chart. So basically, what is the equivalent of it? So if there is a first command if, so if the condition, then do this. So this is the block 1, okay? But if it is not, then it checks in another condition, else if. Okay, if the second condition is satisfied, it does the block 2. It's here. But if it is not, it goes to the second else if command, and it checks the condition. If it is done, it does this operation. If it is not done, it does this operation. So this is the block 4 and this is the block 3. So this is one Potato code structure. You see that it is much more efficient, and it looks like the commands that we enter to the computer. So what is the alternative of it? Of course, we may have different structures and different commands. This depends on the programming language or mathematical package that you use. There are case selection. So select case. Then what you do is you say that, okay, put an expression here. If case 1, so if this expression or x is equal to 5, for example, do this. If it's not, okay, no problem. If x is equal to 10, do this. If it's not, no problem. If x is equal to 20, for example, then do this. And if any of the cases doesn't match, if the case is not one of those, then do block for. So basically this follow chart and this follow chart does the same thing. You see the comments. You can also do this structure in a just by using the if conditions, okay. But as we will see, there's a problem with the CPU time, because we want we want to use the computers in a time efficient way. And certainly using there are some small differences between using if conditions and such kind of a case structures. It mostly depends on how the programming language works. So how the command is converted into an assembler in real applications. Okay, so let's look for another one. Here's another follow chart. For example, we have a junction, so we begin the code. There's a block 1, there's a command, something to do. There is a conditional statement. Okay, if this conditional statement is true, then get out of it. If this conditional statement is not satisfied, if this is true, do something else and get out of the loop or get out of the structure. And if it is false, go to the next command without doing this, and then go to the start. As you see, the code doesn't exist and there is a loop here in the structure, okay, and this is an infinite loop. Generally we put another conditional statement, so until this condition is satisfied, you cannot get out of this loop, as you see from the Potato code. Okay, so this is an infinite, some sort of an infinite loop. So conditional loop with a conditional statement. Of course, in Fortran and in MATLAB, there is specific commands for it. We will see it also in the forthcoming courses. So, such as in Fortran, this is while. I think as far as I remember, in MATLAB also this is while. And this is the Potato code of this flow chart. So it is first do block 1, then if check the condition, if this condition is satisfied, exit. If it's not, block 2, and then do the block 1. This is the Potato code of the structure. So there is another structure. Again, we have a loop. Now we have a do loop with a certain step size. Okay, you can put some sort of a conditional statement here, but it is basically a do loop again. So you do an operation starting from a number, ending with a number with a given step size, and you do something here. So it is like this. If I is bigger than certain number, then exit. If it is not, increase the I with a given step number and then continue. Do the block. This is the other step. So these are the structures of the code, and generally this is how we begin writing a code. These are the first steps that we do when writing a code. First we write the pseudo-code, we design the structure in our head, and then we begin to put the commands into their places step by step manner.